All right, welcome back, gang. So here we are, we're in lesson 11. So in lesson 11, we we go through and talk about sorting. And we've discussed sorting, the logic behind it, in other lessons. And this being the last lesson that we have, if we jump into the text itself, we've got the 5 different types of sort. And for each type of sort, each of these different algorithms, we have a different logic associated with it. And each one has its own time complexity. Okay. And we had talked about our ability in previous lessons. Let's say in the lesson before this, lesson 10, we dealt with search algorithms. Well, now we're dealing with sort algorithms. And in sort algorithms, as we noted previously, we have the ability to, if let's say we're playing a card game, we're playing poker, and I've got 5 cards in my hand. I will sort them depending on if I'm left-handed or right-handed. I will sort them left to right and move from left to right, looking to see where does this go in the sequence. And if I go from left to right, it's going to be a big O complexity of n, because I've got to go through each and every item. There's got to be a better way to go about things. And when we looked at different algorithms and conceptually attacking these structures in different ways, excuse me, we discussed the concept of a divide and conquer. Well, let me break it up, and instead of dealing with n, I'll deal with 2 groups of n divided by 2. I'll do it at the same time. If I'm searching, I'll go with one or the other. But if sorting, well, I'll just go sort them. And I can logically go through and sort them in a way that here, if I'm going in a linear fashion, I compare and I work my way right on down the line. Comparing, swapping, comparing, swapping. Here's that n that we were talking about. It's not very efficient. There's the logic to go through the bubble sort. And we're just doing 2 at a time, and it's going to take us a while. If I have things sorted, it makes it easier for me to do an insert, because I don't have to go through front to back. I can use divide and conquer and do it considerably faster, because to be able to do an insert at a specific position, I have to know where that position is. Instead of going from one end to the other, potentially an n, let me do divide and conquer, and my insert will be more efficient. But if it's sorted, wow, I can do that insert so much more efficiently. Now, we've got the other different sort algorithms that we have available to us, and quick sort will do this divide and conquer that I spoke of. And we essentially break our list up into 2 sections, and then break it up even smaller, break it up even smaller, break it up even smaller, then sort them, and then go reassemble them. And where do they fit? And there's a degree of efficiency there that's better than n, but it's still, that's not the best that we're going to deal with. And then we've got, beyond that, we've got other, we've got temp sort, and variety of different types of sort. Okay? We're not going through and programming and playing with the sort algorithms in this lesson. We'll discuss them, and at this point you understand the logic behind why you would use one and not the other. We've got a discussion, we've got this video that you're watching now, and then we've got the reading that we just went through. Tasks wise, you've got two things ahead of you. I should have bonus points built in there as well that you should see to submit a course evaluation to get some bonus points. But I want to focus on, we've dealt with reflections lesson after lesson. I want to deal with what's going to happen here in this learning outcome number 8, where we're dealing with test plans. Okay. I'm going to open that up in a new tab, and at the same time I'm going to jump into, let's jump into resources. And in resources, I have 3 videos here. We've got the GitHub link from the publisher, and I've got 3 separate walkthroughs to implement, 2 for PyTest and 1 for unit test. Now, there's 2 different ways to go about this assignment that we're going to deal with. This, the project for lesson 11, the developing test plans for quality assurance. So we need to test to find if our code does what it's supposed to do. So we've dealt with, for the most part, checking to see if our code's efficient. What's the time or space complexity associated with it? We also want to make sure that it functions as expected, and find a way to deal with a test. Now, there's a couple of ways that we can test. We can test the speed efficiency and see how long does it take to run. That's not the way we're going to test our code today. So I'm going to pop back to where we were. You know where the resources are to help you with this. Let's jump into this project. Now, it's an individual project. It's just you. You're not working in any groups. Okay? And I want you to understand the importance of software development in what we're doing. So we're going to utilize either one, either unit test or PyTest, in a Colab Jupyter Notebook environment. You can use any of your notebooks that you've created for this course so far. So any code that you've created, submitted, any of the notebooks that you've submitted to date, you can use for this assignment. And you've created things where you've implemented different algorithms, you've implemented different data structures. So there's things that you've done, and now all I want you to do is use that code and apply a test to the code that you've created. It's an example of using unit test to test code within your notebook, depending on what code you have in your notebook. Okay. So we have dealt with a variety of different things. So no 2 notebooks are going to be the same because everybody's got different code and they've got different things they've done. So you're going to utilize the notebook that you have, choose either unit test or PyTest. Got 2 videos for PyTest and 1 video for unit test. And then you will implement these, either one of these libraries and the functionalities associated with them, to test some aspect of your existing notebook. Why do we need to do this? We assume just because it ran for us that everything's good. We need to test to make sure. So here's ways that we can go test the code to see, does the code actually function? Right. Is it going to throw an exception? Try different things, see what happens. Right. You don't need to resolve whatever the issue is. That's not what this is about. This isn't, oh, find an issue and go fix it. All we're dealing with here is taking existing code, using a utility that already exists to perform tests on the code. Your code may pass any test that you hit it with. You may hit it with a test that throws an error, there's an exception, whatever it may be. Okay. So, with that said, go through it. You have any questions, anything you don't understand about what's going on, reach out, ask questions. There's a rubric of how it's being scored. Comprehensive test plan covering positive, negative, and edge cases. Just checking to see what happened in your code. Did it work? Did it not work? What'd you test? So, with that said, that's our module 10. That's the last module here. Okay. Like I said, I'm going to have for you just bonus points associated with completing the course evaluation. There'll be a link down at the bottom here for that. All right. Ask any questions you may have. I appreciate you taking the course. See you in another course here at the college.